Welcome and thanks you for joining us in the last session today. I hope you are really having a great day and you are taking a lot of insights home. And now we are going to take a step back and we are going to reflect on one question. Are you ready for what's next? Are you ready for what the future is going to be asking from your business? We are going to take a look at AWS databases and showing you how AWS is looking at the future to make sure that never change a running system is a saying of the past. My name is Pilar Garcia. I'm going to present today with my colleague Dina Hussein. We are both solution architect managers here in Germany. And we want to take you on a journey which starts acknowledging that we live in a time of change. And while we understand that it's super important to embrace change as a sign of progression and innovation, we really don't think that change always has to be disruptive. You can embrace change, and you can also make the things that are working today to keep working. We know you have invested a lot of time on your technology, we as well. You have invested a lot of energy on your platforms, your databases. We want to embrace change and don't make additional risk to our business. And change is inevitable, so we have to be ready and prepared for it. And AWS has been investing since 2009 in the database space, since we introduced RDS. And we have been working on innovations who have made a lot of things possible and advancements in the data management, like introducing features, for example, like limitless capacity and also pay-per-use model, which have triggered a period of rapid innovation. And you see, innovation has kept accelerating. For example, there's also one big innovation like managed databases like DynamoDB, who have introduced a single-digit millisecond response time at almost any scale. And I want to give you now a lookout on how AWS sees an innovation roadmap and how are we looking at the future. So when it comes to our recent innovations, we like to see data at the center of it. Data is the focus. And we see still a lot of customers come to us and wanting to get more value out of their data. And what are we doing to support them? We want to give you a single unified view to your data, abstracting the technology away so that you don't have to take a look at the systems underneath. You don't have to know how it's stored, how it's interconnected, and you can focus on acting on your data and looking for business value. We are providing low-code, no-code conversational interfaces to developers who want to abstract the technology, but we are also providing APIs to developers who want to dive deep. And your data, we know it's stored everywhere. So you have data on premises, you have data on the cloud, you have data in the SaaS applications. And we want you to be able to catalog, govern it, and query it wherever it lives. And we are working to make that possible. And we also know that there is a difficulty to find a common language between IT and business. And maybe you are working in IT and you are working closely to your business, and we are going to be pushing you to think about why are you going to make your next technology change? What is your business outcome you want to achieve? And how are you going to measure success? And in order to provide you help with that, we are going to offer you natural language interfaces where you can really define your business goals, and your system will adapt to those business goals to make that possible. And we are really focusing on making a lot of investments in this space. And we are also investing AI in things like you have already heard Q for SQL and Q for SQL in Redshift, which is going to be making possible to put GenAI to work for you in create and augment queries. And we are also using AI in ETL pipelines to create data, which are data pipelines for you. And machine learning is also going to provide us possibilities to optimally scale your systems. So you are going to be using, for example, AI/ML to recognize patterns on your queries, and your databases and your systems will adapt to that optimally. And with all these innovations, application development has never been as accessible as today. I don't know if any of you already used the GenAI application tool, PartyRock, but if you didn't do it, I invite you to try it out. These kind of GenAI application tools with low-code and no-code possibilities are going to be making the space for application developers bigger. We are going to get a lot more application developers because this is going to become a core competence from many new people. And the shift is going to turn into the demand to access the data more effectively across different systems, and also to make data available to many different kinds of applications with different demands. And for this, we are investing on zero-ETL. So if you have been working on ETL jobs, you know that they are difficult to build and maintain. They are brittle, they break, they require custom code. We have even seen this custom code be programmed in Excel. So we really want to help customers to be able to connect their systems to access the data easily. And in order to provide zero-ETL future, we are making a lot of investments. And another benefit of zero-ETL is shortening the learning loop. So we can really get access to quickly generated data and quickly put it in the transactional database for analysis and predictions. And access to rapid predictions allow for adjustments in the learnings of your products and the learnings of how your customers are interacting with your products, and you can use these learnings to create business insights. So let us take a look at use cases where business demands almost real-time integration between your operational databases and your analytic engines. So detecting fraud, providing personalized online ads, and also supply chain optimization, making sure that your stock is available at all times in all places you need, are use cases where speed matters. And what are we doing to support these use cases? We are expanding our zero-ETL capabilities, bringing together the transactional data from the databases you love to the analytic engines like Redshift, which are going to provide you new capabilities to have business insights. We previously launched Aurora MySQL to Redshift, which is providing consolidated insights from many instances, which are sending the data in parallel with high performance so that you can really create these insights. And based on your feedback, we are extending these capabilities to other databases like Aurora MySQL, RDS, Aurora PostgreSQL, Amazon RDS for MySQL, and Amazon DynamoDB. But what about unstructured or semi-unstructured data? It doesn't always map nicely into a schema-based model. An alternative for unstructured data is to use a search engine to help with many logical and analytical use cases. And this is why we are expanding our zero-ETL offering to Amazon to connect Amazon DB with zero-ETL and no-ETL pipelines to a fast path to Amazon OpenSearch service. And this way, we can really use the scalability and the consistent query of DynamoDB and provide a fast path to OpenSearch, enabling text, hybrid, and vector search on DynamoDB data without having to move the data from one place to another. And service integration is really critical for the flow of data. We want you to be able to choose the service you need and don't have integration concerns, so that you can really use the service which is best for your business and not take care of the plumbing between the services. And now that your data is connected, you have to really govern it. And one saying I really like, one quote which is really nice, is discipline equals freedom. So contrary to the popular belief, if you have good governance, you will move faster. So you can put rules and guidelines in place, and you can really set data free and organize people around the data and focus on acting on it and creating insights for your business. And Data Zone is really setting your data free. You will be able to create catalogs of highly curated business data and create projects and put the people you need around those projects working with that data. And this is going to help your business to move faster. And our customers are also asking us about how can they really make people working with data also more productive. And you have been already hearing about Amazon Q probably all day, but there are some nice features which really help to get rid of some cumbersome tasks related to data. And for example, with Amazon Q for Business, you are going to be able to ask questions to your data, and you will get automatically visualizations of that. And you can also use Amazon Q in Glue, and you are going to be able to create data pipelines with machine learning. And Amazon Q generates SQL in Amazon Redshift is going to really give you a conversation possibility with your system and help you create complex queries, which are going to really be making job a lot easier. And you can also share these queries with your system and get feedback back. And on the operational side, performance and cost will be always one thing we are very proud of being optimizing. And we are going to be taking a look with machine learning, how can we understand better your system and make sure that you can give us your business outcomes and where you want to be in the performance and cost scale, and make sure that your system optimizes in this space. And for example, with Amazon Redshift serverless scalability, auto-scaling capabilities, we are going to be able to really understand how the system works and optimize it in your behalf. And this is going to be one of the things we are going to be investing in the future as well. And when it comes to cost and performance, one of the things we have made big progress on and we are very proud of is Amazon Graviton 3 EC2 instances. And we are providing so we are improving our data services, which we are making available to run in Graviton 3, which is the third generation of Graviton 2 instances, making 25% better performance on top of the 40% cost performance improvement from Graviton 2. And this is really a huge benefit for our customers. And it's really, really rare in technology that you don't have to make trade-offs, because Graviton 3 costs less, runs faster, and consumes less energy. And for everything else, you will need to make trade-offs. And if you are interested in getting some guidance on how to do architectures which are ready for the future and adaptable to change, I can really recommend that you go back to YouTube and take a look at Dirk Frönes and Gregor Hopp's talk from last reInvent, which give a lot of insights on how to take trade-off decisions. And now what you really need is a good, comprehensive set of tools for your data foundation. Because as you have heard today, for Gen AI, we are really making available the best models to all of our customers. And when it comes to build applications, you are going to be making it your differentiator based on your data. And you have to make this data available across all your services to be able to develop these applications. And for that, we have really a very good offering with a broad set of relational and purpose-built databases, which can help you move faster. On the relational side, we have Aurora and RDS, supporting both open source engines on Aurora case and open source and commercial engines from the RDS side. And we have really purpose-built databases which are optimized for the use cases they were built for. And I'm going to be showing you some of our innovations in this space. For example, Amazon RDS already supported some open source and commercial databases and engines, but we are now introducing a new engine which is IBM DB2. And IBM DB2 is very long in the market, for 30 years, and many critical workloads are running on DB2. And this is why many customers were asking for this feature. And now they are going to be able to move their applications to the cloud and benefit from a managed service without the need of refactoring their applications. And with Amazon RDS for DB2, they will get all the benefits, and you will get all the benefits from the cloud and from a managed service like high availability and multi-AZ deployment. And when you log in your database, you will be able to recognize the database you have been using a long time. And you can also benefit from the migration tools which IBM and AWS have implemented together to make sure that your migration is very easy for you. And this is something which also reduces the burden of change. And another innovation in the purpose-built space is around Amazon Neptune. And Amazon Neptune is a graph database, which was built for transactional data. Amazon Neptune is a graph database which was built to really optimize queries analyzing graph spaces. And for example, now what we are doing is Amazon Neptune to bring it to be a brand and have more products underneath this brand. For example, Amazon Neptune Analytics. And before I go to explain why we built a new service there, I would like to go back to Amazon Neptune database, which is really already being used for many use cases like Customer 360, like fraud detection, or improving IT security. And also on the social media space, Amazon Neptune can really give you, for example, the 10 connections from one individual. And you can be doing these kind of queries on a very, very high number in parallel, and Amazon Neptune is great at this. But there is a different use case, why we build Amazon Neptune Analytics. And Amazon Neptune Analytics is also a graph database, but it's able to really analyze tens of billions of connections at one time. So when we go back to the social graph example I gave you, you are not only going to be able to ask for 10 connections of one individual, but you can scan the whole social graph and really rank the social influencers. And Amazon Neptune Analytics is able to do this almost, in many use cases, 80 times faster than systems existing today. Amazon Neptune Analytics is also providing vector similarity search capabilities, which you will be able to use with your GenAI applications, like you will see later. And we are not only offering new services, but we are also improving existing service, like Amazon Aurora with now limitless database capabilities, or Elastic Cache with serverless capabilities, which are really responding to the ask from our customers to improve scalability and also to provide capacity planning support. And with Amazon Aurora, we can already scale to very large databases. But one of the things we are seeing is almost more and more data coming in, and also more I/O throughput requests. So now with Amazon Aurora Limitless Database, what you will be able to be doing is what we know in the market as a sharding solution. And with this sharding solution, you will be able to scale to almost 10 million of writing queries in parallel. And how does it look like in the back? I don't know, maybe you went today to the deep dive on Amazon Aurora. You might have seen how this works, but in a nutshell, your client application will look at one single database. But when you make a transaction, the service will automatically go to the appropriate shard and make your query possible to be done in parallel a million times. And what we also have is Amazon Serverless Aurora version 2 in the back, which will make sure that you have a scaling capability and cost optimization for you. And customers are also coming to us, telling us, well, cache configuration is really hard. And cache is really difficult to be planning the capacity we are going to need. And this is why we are introducing serverless features in our Elastic Cache service, which are going to provide you with Our last version of Redis 7.1, being able to do 100 million of transactions per second and having 500 instances per cluster, you will be able to do 500 million of transactions per second, which is really almost covering all the business needs we have heard from. And in the back, it looks very similar to Aurora. For developers, you will see a single cache endpoint, which would make it very easy to use. And we will have also operational teams not having to take care of the infrastructure. And underlying operations teams, we also have multi-AZ and recoverability capabilities, which they don't have to take care anymore. And you can also use this infrastructure to have automated security patches, which will also make the maintenance of the system a lot easier. And now we have covered a lot of innovations and investments we are making to really be ready for what is to come. And we are ready to keep investing in all the things you are going to be needing to reduce your operational burden, to really improve your productivity, and on seamless scaling our services to meet your business needs. And now I would like to call to stage my colleague Dina Hussein, who is going to be talking about how we are making databases future-proof for GenAI applications. Thank you very much.
Thank you so much. Thanks, Pilar, for showing us ways on how to manage and act on all of our data, regardless of where it lives. In fact, we do believe that the real value out of generative AI applications is unlocked when our proprietary data, including our domain knowledge, our policies and regulations, is integrated with GenAI technologies to deliver real-time, accurate, and context-relevant applications. In the second part of our session today, I'm going to be focusing on the role of vector databases or databases enabled with vector capabilities to bridge the gap between foundational models from one side and GenAI applications on the other side. My name is Dina. I'm Solution Architect Manager at AWS. One question first before we start. How many iceberg slides did you see today? 3, OK. 1, 3. For me, it's 2. 2? OK. All right, I will make a promise. This is going to be the last iceberg slide you'll see today, because it's the last session. All right, so as you know, GenAI is like an iceberg. There's a lot above the water, and there is even more beneath the water. Starting first with foundational models. And let's break it down to problems. First, how are we able to process huge amount of data, which requires huge amount of computational power, which costs lots of money, requires time and expertise? And how are we able to break down complex tasks into smaller ones to be able to process these in parallel? Foundational models is the answer, or actually, it's, to be more accurate, it's part of the answer. Foundational models are a kind of machine learning models which are pre-trained to perform broad range of tasks. For instance, language tasks, and those are specifically called large language models, LLMs, and so on. And as I said, foundational models require lots of computational power, and thus big companies like Amazon, Meta, Anthropic has made those models available for us to use. Now another problem. How are we able to tailor the outcomes of these foundational models to fit our domain knowledge, our regulations, policies inside companies, etc.? Well, by feeding those foundational models with our proprietary data, which are stored in data stores, we're able to first tailor the outcomes to fit our business and our needs, and second, we can query those foundational models using APIs, for instance. Okay, third. What about complex data? How can we store complex data in a language which AI can analyze and understand? This is the role of vector databases, or databases enabled with vector capabilities. And vector databases, in essence, translates complex real-world data into a language which AI can analyze and understand. They are used widely for executing complex AI tasks, for instance, image processing, image recognition, language processing, for instance, content generation like text, audio, video, or code. And it's very known in the generative AI world. Lastly, what kind of use cases can help us generate value out of GenAI based on patterns learned from our data? Agents, Bedrock agents can be one of those examples. And Bedrock agents are fully managed Bedrock capability, which can automate tasks on behalf of our customers. So we can generate an agent that can help the customer process an insurance claim, or an agent to help the customers make travel reservations, or an agent, for instance, to help customers return purchased orders, etc. And as I said, agents are fully managed, meaning that you don't need to write any code, you don't need to provision capacity or manage infrastructure. Agents will automatically, actually thanks to Bedrock, so Bedrock will do the heavy lifting of providing the prompt engineering, the memory, the monitoring, the encryption, the access control, and even the API invocation. So this is pretty powerful. Something very important here, the key is your data. And if you're going to be using the most recent, or the most advanced foundational models with whatever data, then you're going to be getting the same outcomes like anyone else in any part of the world. However, your domain knowledge, your data, and your expertise is very important to bring to the GenAI, to the GenAI environment to unlock its full potential. All right, stop talking. Now let's go to the practical example. Today, we're going to be all working at an online shoe store. And we have a customer who came to our website or mobile application, and they said they have purchased a pair of shoes, and they would like to exchange them with a different color. We're going to be all helping the customer do the exchange in the GenAI world. Few steps first. One, we need to be defining some steps to orchestrate how we want the interactions between the GenAI model and the customers to flow. Secondly, we're going to be configuring the foundational model to access our proprietary data. Remember, this is about our policy and regulations, etc. Third, we're going to be completing a series of actions to make sure that this return is following our policy. So we'll make a decision whether our return policy allows such a return. And finally, we're going to be executing some tasks in the cloud to make sure that this is a secure, well-functioning, and it's a well-monitored application running in the cloud. Let's dive deep. Here we have one problem, the first problem, how to make sure that the customer order is legit, that the customers actually purchased the shoes via order number. So we're going to be chatting, the agent is going to be chatting with the customers, asking them to provide the order number. And when we have the order number, we're going to be doing a fact lookup against the customer orders database to make sure that this order is legit. And we're going to be also asking the customers to provide the ID of the item that they want in return. All right. In the second step, this is a very important step because this is where the operational database will come in. Here we have two problems. One problem, okay, how to make sure if we have stock, available stock from the item that's required in exchange, right? That's one problem. The second problem, how to make sure if our policy actually allows for such a return. So to solve those two problems, we will need to do two kinds of interactions, and both are GenAI based. The first interaction, to figure out if we have available inventory on the item that's required after we do the return, we will need to do a fact lookup. It's simple. It's a fact lookup against our inventory database to figure out if we have available stock on our database. That's one thing. All right. To solve the second problem, remember about the policy, this is a little bit more complex. Here we need to perform vector similarity search, or VSS, against our policy repository. What's a policy repository? Policy repository, it's a kind of documentation that we have already available on our website or mobile application, which is listing our commitments towards the customers when it comes to returning. So basically the return policy and the conditions, etc. Okay, and what's a vector similarity search? A vector similarity search, without going into many details, because today I want to keep at the operational database level, is a mechanism used a lot in information retrieval and in data analysis. And the purpose is to find the closest data object to a given query vector. And I will explain later what vector is. Right? So here we need to perform actually a mechanism, and both the two interactions that I talked about, the fact lookup and the vector similarity search, are both kind of RAG. RAG is a very famous term used in GenAI. It's retrieval augmented generation. what RAG is about? RAG is a mechanism used to enhance the quality and the relevance of text generated by foundational models. How? By finding whatever data, knowledge, information, document, basically any knowledge that's relevant to a given question or a task, and feeding it back to the foundational model to enhance its context. So both the two kinds of interactions are RAG, and if you can think about it, if we are using the latest and most advanced foundational model without feeding it with our proprietary data, so without performing the RAG, we wouldn't be able to answer the questions, whether we have stock and whether our policy allows for return. So RAG is a way to customize the foundational models based on our domain knowledge. All right, in the third step, we're going to be the biggest problem here: how can we execute these steps fast and efficiently? And a way to do it is actually to break it down into more simple tasks, and each simple task is going to be eventually an API call. And there are several ways to, one of the examples of an API call is an API call, for instance, to figure out if we have enough inventory on our repository database. And to perform this, there are several ways to do it. Here, I'm using Lambda functions. And if you've been following the announcements from reInvent 2023 last year, and perhaps today, we talked about Bedrock agents. And I talked about it even today. You can use Bedrock agents to perform such, break down the complex tasks and do the API invocation. And lastly, we're going to be performing some steps. I know that you are all experts in the cloud, so I'm not going to go through the details, but we need to perform some additional steps to make sure that this is a well-hosted, monitored, secure application running in the cloud. Here, this is very important. Let me stop here a little bit, and let me repeat again. So we believe that the real value out of GenAI is unleashed when our proprietary data, including our knowledge, domain expertise, policies, and regulation, is integrated with GenAI technologies to deliver real-time, accurate, and context-relevant data. And here, the role of vector databases is essential. It's bridging the gap between foundational model on one side and GenAI on the other side. And since our operational databases are storing majority of our applications' data, then they play a critical role on how engineers and developers can leverage it to build AI-assisted applications. All right. Back to our example. So just a little bit of a recap. We have the customer who came to our website or mobile application asking to do the return. And now we need to read our policy documents. We need to understand the words, the phrases, the sentences in the policy documents to make a decision whether we can allow such a return or not. And how can we understand the meanings of the words and sentences and phrases and other data types? Via vector embeddings. And vector embeddings converts sentences, words, phrases into numbers, which represents their meanings and the relationships. And are we going to do the vectorization ourselves? Actually, Bedrock is going to be performing this heavy lifting, first by chunking the data. Why do we need chunking? Yeah, because we need to be able to read the many policy documents, and we need to be able to chunk it into smaller inputs to feed it to the foundational model. So this is the chunking first, and then it's going to be performing the vectorization on our behalf. And the output of this step is going to be vectorized data, meaning a series of vectors, which is basically representing what's going on in the documents. All right, and then, so here we have the data chunked, vectorized. Now it needs to be clustered according to its similarity, right? And how to represent this clustering? It's represented via vector space. And what is vector space exactly? It's actually a conceptual framework or a mathematical model where data is represented as points or vectors in n-dimensional space. You can see here, it's actually 3 dimensions because I don't know how to draw an n-dimensional space. But the point I want to bring is that each dimension is different. It will contain data about a different topic. So each dimension is not relevant to the other. So in one dimension, we can have data about shoe styles, for instance, tennis shoes, sneakers, etc. Another dimension about shoe colors, and a third dimension about seasons, and then a fourth dimension about the policy, about the policies itself, the return policy, etc. And each dimension is different. And in order, since similar objects are close together in this n-dimensional space, then the similarity can be computed based on the distance between the objects' vector embeddings. And this is how we're going to be performing vector similarity search. We're going to be looking for the closest neighbor in an n-dimensional space to figure out about the meanings and the relationships inside the document. All right, here, from a holistic view, we have been reading the document, so we fed our machine learning with our document, we read the document, we did the chunking and vectorization of the document, and we stored the vectorized data along with the core data, right? So the operational data in a vector-enabled database. In this example, we're using Amazon Aurora Postgres with PG Vector. And then we're going to be feeding the foundational model with our vectorized data along with our core data, and it's going to be making a decision whether to allow such a return or not, which is, in our case, let's assume it's a happy ending. And then this is from a customer perspective. We have the customers on the customer on the left-hand side. They are querying against an agent. So they're asking, oh, can I do the return, please? So they are querying. And the answers are actually taken and ingested into the Bedrock environment, where there's going to be the database. We're going to be having, again, the operational data and the vectorized data, and it's going to be feeding it to the foundational model. And the outcomes will be the decision whether to allow such a return or not. So this is from a user perspective. Actually, it's important to mention here that our customers, Adidas, benefited from the same technology. So they used their proprietary data with Bedrock to build a knowledge base, allowing their community of engineers and developers to find answers to questions, either getting started or very complex questions, using a single conversational interface. So they use the same technology, and this is very, very powerful. All right, so in terms of vector databases, speaking about it, what kind of vector databases are there? There are so many kinds, and they're all great, and we're going to be giving you in AWS the best advice about which vector database fits your data and fits your business. However, there's something that we keep hearing consistently from our customers about how they prefer to store their core data, their operational data, along with their vectorized data in one place. Why? Several reasons. One, because they don't need to manage upskilling in yet a new technology. Second, because of licensing. They don't want to manage additional licensing. Third, because they don't want to handle lots of data movements, because you will need both kinds of data, the core data, the data that's the proprietary data, and the vectorized data. You're going to be needing both for a generative AI application anyway. So instead of handling lots of data movements and data syncs, it's better to have it in one place. And this is actually leading to the reason number 4, which is a speeding up time for innovation. So just making the lives of engineers and developers much easier, because anyway, they will need to combine those two kinds of data for Gen AI or for any AI applications in general. All right, and this is why we're working on our portfolio of database engines to embed it with vector capabilities across all of our database engines. We successfully did this with 7 engines, as you can see here on the screen, the last of which is Amazon DynamoDB. All right, and here is one main question, one main problem we need to solve: how to get started, and how can we bring our data to AWS and to all these different engines. Actually, our main tooling for this is a tool called the Data Migration Service, the DMS. And every year, we are happy to share our vision, the roadmap for our services. We shared the vision for DMS last year during the reInvent 2023, and I'm happy to share it again with you today. First, when it comes to discovery, the main tooling there is a Fleet Advisor. And a Fleet Advisor is a tool which you can run onto your portfolio of databases. It can scan your databases, and whether you're using the same technology at source and target or using different technologies, it will give you an estimation, a t-shirt sizing estimation, small, medium, large, regarding how much effort you need for migrating your databases. And this is quite powerful if you want to prioritize your migration based on the amount of effort including in it. So this can be, the Fleet Advisory can be very powerful. Second, related to the schema conversion and data migration, our main tooling is the schema conversion tool. And we're working also on the automating the tool. So we are, the tool is actually opening the source databases, and it's figuring out which tables need to be transferred, and it can operate the transfer, it can execute the transfer in the background. Also, the SCT has been a PC, used to be a PC-based, now it's a web service-based, and it can be looking at the queries running at your system, and it can be doing the schema conversion in the background. Lastly, when it comes to validation and testing, we're working on improving our ability to test the data and the outputs of the queries to make sure you're getting 100% of the results you're expecting at the target system before you cut over to it. So as you can see here, throughout the whole vision for data migration, automation is the big title. We're working on automating the entire life cycle of migration. Something also that we're very proud, and we're very proud to announce every year, we announced that last year, our contributions to the open source communities. So in 2023, we have made more than 550 successful contributions to the open source communities of MySQL, MariaDB, Redis, and we're super, super, super happy to share those announcements. And I think it's very important for the communities, and actually for us, we both mutually benefit from this. All right, so here are a summary of the database launches that Pilar and I have been talking about today, and we've announced these in 2023 reInvent. So before ending, I would like to thank Pilar again for showing us ways to manage and act upon all of our data, regardless of where it lives. And I want to say that in each step, we come closer toward the vision where we are removing complexities and allowing you to innovate more. And our vision and our goal is to enable you to run your systems with operational excellence. And that serverless is the new normal. So whenever services can scale up, scale down without having you manage capacity or infrastructure, this is how we want all of our services to operate. And our services are proven both in terms of performance and scalability, and we're working every day on enhancing the interoperability to make sure that the applications written for those services can run at almost any global scale. Last but not least, actually, if you are interested in any of the technologies I talked about today, of me or Pilar, or any of the sessions that you've been attending today, please scan this QR code to join our Skills Builder page. I don't know if there will be lots of iceberg content there. No idea. And yeah, finally, change is inevitable. I think you started the introduction saying this. So our goal is to meet you where you are and help you achieve more. And you can trust that our ongoing commitments to innovation will make sure that your data foundations are future-proof to change. Thank you so much. I'm very looking forward to work with you. Thanks for
Thank you.
myself.